Okay, so in this next segment, we're going to go over classical machine translation. So I'm going to give a very high-level description of various systems that people developed in the first few decades of machine translation, and this will give us some very useful context in thinking about how we might design different machine translation systems. The systems I'm going to describe are all rule-based methods. These are methods where humans would try to hand-build translation systems. For example, compiling dictionaries or bilingual dictionaries specifying how words in one language would translate into words in another language. So early machine translation systems made use of a method called direct machine translation. These methods essentially perform the translation process word by word. So if you have a sentence in one language, you would essentially word by word try to map it to words in the other language. There was very little analysis of the source language text. Okay, so you can imagine that it might be useful to maybe parse or at least tag the source language text to get some idea of the structure of the underlying sentence you're trying to translate. But these direct machine translation systems really did away with any analysis of this form. They relied on very large bilingual dictionaries. I'll give an example in the next slide, where for each word in the source language you would specify a set of rules for how to translate that word into the target language. In terms of reordering, so there was always this problem that if we have words or sentence in one language that we may want to reorder things, we may want to move things around. In direct translation systems, usually a simple set of reordering rules was applied after the word-for-word translation had been performed. So for example, in English, you see the adjective like blue before the noun dog, whereas in French, sorry, my French is terrible, but I think this is correct. You would see dog translating as this word, blue translating as this word, and notice the order is reversed. And so you would need a set of rules to recover these kind of simple reordering phenomena. Here's an example of a set of direct translation rules. This is taken from the Jurafsky-Martin textbook, and it's originally from, I think, a Russian system from 1960. It's actually, I think, fascinating to look at this. So this is a set of rules for translating the word much or many in English into Russian. And so you can imagine that somebody, some human, has looked at a lot of example translations, or maybe just use their intuition about the two languages to derive a set of rules for how to perform this translation based on the surrounding context. So these rules say that if the preceding word is how, so if you have how much, then you would translate one way. On the other hand, if the preceding word is as, so as much, you might translate a different way. Otherwise, if the word is much rather than many, you would go into some other rules, and so on and so on. So deriving these kind of rules is a pretty painstaking task. You can imagine for any reasonable translation system, you might have at least a few thousand words in a language that you need to translate, and you would have to compile a set of rules for each different word in the language. So direct machine translation systems are rather limited. Let me go over some key problems that they face. One is the following. It's difficult or nearly impossible to capture the kind of word order differences we saw earlier between different languages. So here I have this English-Japanese example again. So you could imagine trying to write a set of rules that, given the English string, predict the word order in the target side and the Japanese side. But that's very hard to do when you have no analysis of this English string. You don't know which words are verbs versus nouns, and you certainly have no syntactic structure. So that's one challenge. The second one is that words are translated without any knowledge of the role, the syntactic role they play in a sentence. some other representation of the syntactic or semantic structure of that English. So that's the analysis stage. In the next stage, we perform what is called transfer. And here we transform, so this is an English parse tree. We somehow transform this to a French. So this is English. This is a French parse tree. And to perform this transfer step, you use a set of rules, maybe rather similar to the example I showed you for Russian earlier. But these rules critically can now refer to the syntactic structure of the English side, so they have more information, and so they can hopefully perform a better job of transferring across to the French side. Finally, there's a stage called generation, where we take this French parse tree and we produce the French strings. This is usually, at least if this is just a syntactic structure, this is a simple step where we just remove the tree and produce the string. So these are transfer-based approaches. We might use various levels of representation at this intermediate stage. We might use syntactic structures, or we might use something which is closer to a semantic structure, closer to some representation of the meaning of the two languages.